Welcome, calculus students, to the chain rule. Our nice introduction there by Aretha Franklin is going to lead us into what we see in section 3.4. So let's get to it. All right, so take a look. F of x, g of x. We know how to differentiate these functions. This is what we've been working on in the past couple sections. But what we're going to talk about today is a function like this, h of x. Now, if you look closely, h of x is actually a composition of the two functions up above. So if I show that composition, inner function would be our g of x, outer function our f of x. So h of x is f of g of x. So how do we differentiate the composition of two functions? We know how to differentiate when we have a product of two functions. We have the product rule for that. And we know how to differentiate when we have the quotient of two functions, because we have the quotient rule. But now we need to figure out what we do with compositions. The nice part is that it's going to turn out the derivative of a composite function f of g is actually the product of the derivatives of the function f, which will be evaluated at g, and the function g. So let's take a look and see what this actually means. This is where we get our chain rule. So the chain rule says if g is differentiable at x and f is differentiable at g of x, then the derivative, so we're going to use our d dx notation here, the derivative of our composition f of g of x, get all those parentheses in there, equals the derivative of the function f at g of x multiplied by the derivative of g of x. All right, so let's use a different notation here. So we have a composition f of g, which we're going to find the derivative. So f of g prime of x equals f prime of g of x times g prime of x. All right, so get those copied down. We're going to try this on our example that we just took a look at, h of x. So we need to find h prime. And the first thing you want to do now is take note that this is going to be a composition of two functions, so we have to use the chain rule. All right, so from before, I already showed you what the two functions are going to be that create h of x. But let me rewrite it here. So h of x, again, we're going to say is composed of two functions, f of g of x and f of x. That's going to be our outer function. And that's just the square root function. So the square root of x, again, this is our outer function. And then we have g of x, our inner function, which is our cubic polynomial. Okay, so think about what we said. For this derivative, the first thing we need to do is find the derivative of f at g of x. Okay, well, let's go over to the right side here for a second and think about f of x. F of x is the square root function. Okay, so if we're going to take the derivative of f of x, what we're really doing here, if we remember, derivative is 1 over 2 root x. But we don't want the derivative of f at x. We want the derivative of f at g of x. All that means is we're going to plug in the g function where x was. Okay, so my derivative of f at g of x is going to be 1 over 2 times the square root of our polynomial, x cubed minus x plus 1. All right, so that's the first part of our derivative. So I'm going to go back here, over on the left now. H prime of x equals 1 over 2 times the square root of x cubed minus x plus 1. Okay, that's only the first part. Our second part here, we need to figure out the derivative of g of x. Okay, grab a different color. I'm going to go back over to the right side, get a little bit more room here. Okay, so g of x. I need g prime of x for the second part of my derivative. Now that's just a polynomial, so it's going to be 3x squared minus 1. Okay, go back to my derivative. So for h prime of x, I have the derivative of f at g of x already there, and I'm going to multiply it by my derivative of g of x, which is 3x squared minus 1. So let me rewrite this. The derivative of h at x is going to be 3x squared minus 1 over 2 times the square root of x cubed minus x plus 1. All right, so let's take a look at a couple more examples so you guys get the idea. So starting with number 1, we have y equals x squared plus 4, and all of that's cubed. Okay, so we'll identify our inner function and our outer function here. So if I consider this as the composition of two functions, my f of x function, the outer function, that would be our variable here. So we have something being cubed, it's outside, so x cubed. Okay, in this case, x is representing the interior function. Now my g of x function is what's on the inside, x squared plus 4. Okay, so I know what my two functions are, and now I know that I have to differentiate using the chain rule, because this is a composition. So let me change up the color, go over to the right here. I got y prime equals. So I know that I'm going to need first my outer function. I'm going to take the derivative of that at g of x, so at my interior function. So derivative of f of x, since that's x cubed, is going to be 3x squared. But it's not x. It's 3 of x squared plus 4 squared. Okay, I put that g of x function back in there, but the rest is just the derivative of that polynomial. Now I'm going to multiply that by g prime of x, which is 2x plus 0. So I'm just going to write 2x. Okay, rewrite this in the end. So I have 3 times the 2x, which I'm just going to write as 6x, and then that's multiplied by x squared plus 4 squared, which I'm going to leave as is. Okay, example number 2. I have y equals the square root of 1 plus 1 over x. Okay, so in this case, I'm going to identify my interior and exterior functions, or inner and outer functions. So if I do y equals f of g of x again, my f of x function, the outer function, is the square root function. My interior function is 1 plus 1 over x. Okay, so let me differentiate. Y prime equals the derivative of f at g of x. So again, I have a square root function. I know the derivative is 1 over 2 root x. But instead of the square root of x, I'm doing the square root of my interior function, 1 plus 1 over x. Okay, got to multiply this by the derivative of g of x. So g of x has 1 plus 1 over x. Well, the 1's just going to go to a 0. And for my 1 of x function, I know that that's really x to the negative first power. Sorry, let me go back over here and actually show what I'm talking about. So this 1 over x is really just x to the negative 1 power. Okay, so going back to my derivative, I know that that's going to be negative 1 multiplied by x to the negative 2 power. Okay, so that's going to end up in my denominator as x squared. And I do have a negative sign, so let me combine these all together. I get negative 1 over 2x squared times the square root of 1 plus 1 over x. And that's my derivative. All right, last example here, number 3. Let's get a little bit more room. So we have g of x equals 3 to the 3x squared power. All right, so we already have g of x here, so I can use h of x and f of x as I talk about my compositions. Okay, so let's say g of x is f of h of x this time. All right, so my f of x function, for this one, the outer function, well, that's going to be e to the x. Okay, my inner function, I'll call h of x this time, is 3x squared. Okay, so that power, if e to the x has any power other than x, it's a composition. I have to use the chain rule. So I'm going to go back here and start my derivative. So y prime equals, my outer function again was e to the x, but it's really e raised to that h of x function. And we know derivative of e to the x is e to the x again, so I end up repeating the exact same function, e to the 3x squared. Now I'm going to multiply. So my Inner function, h of x, I need that derivative. 3x squared, the derivative would be 6x. So for this example, y prime equals 6x e to the 3x squared. All right, so that's your introduction to the chain rule. We'll see you in class for some more practice and examples. Have a good day.